my God,
this is
mate,
your
that's
repeated
so
thing
sad.
I've been listening
When
to
you
over and
started
over
this, you
again.
had something,
When you get
and then at
cornered
the
in
end you
this
didn't, and
box,
it's
you start
sad.
talking about us and how our argument is and how sad our argument is, and you just start talking about us. The way we're talking, the way we're arguing with you. Shut the
Buddy,
fuck up.
nowhere
You're
does
here
it
for
say they
round
moved
3
the
to get
string.
knocked out, dude. This is like, you know, Hearns
Where'd they
versus
say they
Haggard. There
moved
was
the
never
string?
fight 2 and 3.
Where'd they move the string?
Boom. I really hate replays, though. I get all into
Anyway,
it.
this is not a precision measurement. This is garbage, dude. Garbage.
Yeah, I'm referencing some experts that built something according to the curvature of the Earth, and it worked. What's wrong with that?
Yeah.
Sounds like another fake
Are they
ass AI.
lying? Do you think they're lying?
I think it's confirmation bias. That's what I think.
Okay, so they specifically machined and came up with a system to make the rail curve to fit what they thought the water would do, and it was correct. And you think that's confirmation bias? How does that work?
Yes, I do.
So if I was to think something like, no, like, you know, if you just use like a base iron to make a camshaft, that'll be fine. Like, it's great. I believe that. Like, someone told me it had worked before because I used it in an old steam engine once. And then you do it and it fails because it's not the correct, like, metal to use.
Yeah, and how is that analogous to this?
So confirmation bias failed in the practical, didn't it?
Yeah, because that's why engineering, you do things by trial and error.
No, you
right.
do
So things are manufactured all the time that fail, break.
Engineering is doing things by trial.
It is.
That's the dumbest thing I've heard. Honestly.
Well, then you've never actually made anything. You've never made. Have you ever made anything in a manufacturing process? Have you ever worked in any manufacturing environment?
Yeah, I've worked in a couple of factories. They're shitty jobs, but yeah.
No, a like an actual manufacturing environment where they actually engineer, design, and make the product, and then have samples, and then the samples are gone through tests, and then you have the production line, and you start making it in production, and then you have to have quality control because not even that is a perfect process. It's called trial and error.
Yeah.
So you you start with an idea, right? You maybe apply some models. And then you engineer some prototypes. Some of those prototypes will work. Some of them won't. Right? So if they could just do it by equations, then they should just be able to fill out the equations, do the math, start pumping out the products without ever testing them.
The one I worked in made fire-resistant suits for firemen. Right? Mm-hmm. And well, it was for firemen working with the army, so it was like armed personnel fire-resistant suits. And what they did is they got the known tolerances for the fire-retarding capabilities of certain fabrics, and then they got their heat sink capabilities of other fabrics, okay?
Yeah.
They added all that in with the dimensions of a human being, and then they modeled that out so that any stitching would be covered, and then everything was cut, everything was manufactured, and they tested at the end to make sure that everything they'd done was correct. But everything they'd done was correct. They then updated it depending on user needs, but that fabric had known properties.
I bit my tongue.
How did they know the properties? Did they use equations or did they test the fabric? So they got the fabric secondhand from somebody.
Someone else did.
Exactly. So they got it from somewhere in that place that manufactured the fabric.
Steel, do you? The manufacturer tests the steel to make sure the grade is correct and then sends it to you.
Yeah, they have test samples. They test samples, right? So they manufacture fabric samples.
Engineers buy things of known properties. They don't test everything.
Yeah, it's known because they tested it to trial and error and figured that stuff out.
Yeah, a long time ago, and now they're known properties. So engineers can make things using those known properties, like the engineers.
Yeah, so they're just using trial and error.
They knew the known properties of that fishing line before they started.
Not within any certainty, obviously.
Not at all.
About 25 kilograms with quote unquote very little stretching. Not the stretching was not quantified. The break point wasn't actually quantified.
And
it could listen.
And
the catenary curve that they calculated existed might not have existed.
Just saying.
How do you know that? You're just coming up with that.
I don't.
If they've had some monumental failure.
Because you think this is a precision, some sort of precision. Listen, because you think this is a precision measurement of curvature.
Precision in that document. How do you know they didn't have the precise properties of that string line and just vaguely referenced it because they couldn't be bothered going and looking it up again?
How do you know these people weren't fucking aliens from Mars and didn't just fucking throw a bunch of random words on the paper? I mean, come on, dude.
We've never seen aliens in existence, but we've seen people in existence. We've seen engineers in existence. We've seen the properties of certain string lines in existence.
We don't see curved bodies of water in existence.
We've seen that when engineers calculate as much stuff as possible and it all works, then it's reasonable to assume these engineers are competent, aren't they?
I'm just saying I know a little bit about this.
We don't see curved bodies of water in existence, so no, that's stupid.
Where, heretic, where? Is that all you got?
You're just assuming shit. Right.
5 minutes is a test.
You're just assuming shit, which is part of the course.
Yeah, it doesn't shock me. Induction. I know it's scary to you guys.
Yeah. Inference and induction. Yeah,
literally
great. Affirming the consequence.
Oh, God. Can you say it again? Inference and induction?
Yeah, inference and induction, yeah.
What's inference?
Inductive logic is hinged on making inferences from observations. Is that not true? Is that not a true statement? Is that not a true statement? Yes or no?
I love this.
Sorry, did you say inferences?
Yeah, dude. How come every time, see, the problem? One of your problems is you talk too much.
What you said properly.
You talk too much. Do you know how many times you have to say I didn't hear you because you're fucking flapping your gums?
People. We're on Discord, mate.
Yeah, because you can't listen and talk at the same time. That's why you can't hear people.
Induction.
Oh man, bravo! Fuck, got my heart. Man, got my blood pressure up for that one. That was amazing. That was so good. And then they cut me off again. Fantastic. I'm like, I actually have some value. I have some input. Damn it! Why is it a replay? Whatever. I guess I can't interrupt Music Bot without getting banned too. Okay. Not bummed out about it. I could talk polymer chemistry all fucking day. Bring it. Just saying. Nobody ever asks me. But whatever. Nobody ever asks. I guess since I'm muted and nothing is playing, it's gonna jam out again. Ski guys, I'm not going home. I'm staying here. Tonight, baby, it's the last day.
Also doesn't lead to concrete conclusions. It only leads to strong or weak, potentials.
Well, he didn't even do that. He just assumed his conclusion in the first place.
Well, no, I didn't. I gave.
Yeah, you did.
So what I have
no,
is a
you
hypothesis,
didn't.
and
you already admitted
my hypothesis is either
you assumed a curved water level. You matched some railings to the curved water level that you assumed, and then went, "Good, it's all curved." That's all you fucking did.
No, I didn't. What they did was they made the railing.
You're right. I misspoke. You didn't do that. That's what you think someone else did.
So we're at the point now of just muting me all the time? We're finally done? Do you want me to just go now? Are we done?
You can do whatever you want.
I can leave if you want. If you're just going to mute me anytime I'm halfway through a sentence.
Well, you can sit here and cry or you can leave. I don't care.
We just told you that, basically that you're over talking. I tried to tell you what the problem was, why it's not a good thing. Because it means you're not listening, right? And we're just wasting our fucking time, which I'd rather not do, right? So
no, I was listening. I just think you're wrong. The reason I couldn't hear some people is because some people are low. So I'm trying to figure out who's talking, whose sound is low, so that I can turn them up so I can hear them better next time. Make sense?
Anyways, Linda, feel free to be a beta and leave if you want, but that wasn't what we were trying to do here.
Why would I be a beta if I left?
And you still haven't proven curvature or anything else. All the stuff you said is crap.
Why do you use the word prove?
I can't even read
evidence, which can never prove anything. It's called the problem of induction.
trying to figure out why they need to compensate for curvature for this design.
Right.
The rails must be aligned vertically to follow the curvature of the Earth. Vertically?
Vertically?
Yeah, the rails must be aligned vertically to follow the curvature of the Earth. Horizontally and in roll in Southampton, Saginaw, oriented a tank of 138 meters.
Yes, that's talking about the
is about
the rail.
0.6 millimeters.
That's talking about the rail, in this case, has little like jacks under it to move it up and down before they set it. So they have to be aligned vertically. Those jacks have to be aligned vertically so that the horizontal lines up with the horizontal curve of the water. What's wrong with that?
I'm gonna make it easy.
Doesn't seem necessary for what they're doing.
Why? They're trying to do
I'm reading it,
measurements of different hull shapes.
Well, do you know what uncertainty and precision is?
Yes.
Okay.
Uncertainty is an unknown, and precision is to the highest degree of measured known.
What?
So for this tow tank, they need to know if there's a deviation in the railing, because that deviation in the railing would cause the hull of whatever thing they're testing to push further down onto the water, causing more drag and changing the results, or to go higher up over the water, which would reduce drag and ruin the results.
Okay, and if they didn't do it right, what would happen? Let's say they did all this process and they did something wrong and they didn't know about it and it's not in this document. What would happen?
What would happen would be that the boat, when they move it along the railing, would experience more drag in some spots than other spots, which would mean they would.
You mean so they're trying to model drag? So this is a tank that's trying to model drag,
amongst other things. Yeah.
I'm sorry, I'm dying over here.
I'm trying to figure out what the even purpose is. It just seems like just some nonsense.
I can answer the question.
If you get a boat and you get a hull design of that boat,
You're saying
some hull designs will go faster than others.
Brother, you're saying the same thing, so we're going to break it down to simplicity. All you're saying is that the rails must be parallel to the water surface. So this entire procedure is to make the rail parallel to the water.
Yep.
Yeah. That's
only the of Earth curvature is in calculations. Thank you.
That's my case. Again, because you were too upset and you cut out.
Well,
or they measured the curvature of the water level that they assumed.
All right, I'll say it
talking again while he was talking. So let me translate in normal speak.
Oh, I wasn't normal speak talking, but I'm talking while you were talking because it's kind of sad to start off like that. So, Arden, do you want to just say what you said again? Because I couldn't hear you because you got too upset.
Yes.
See, once again, talking about how we're talking. You're being exposed. You're a chump, dude. You're just a chump. If you're going to talk about us, I'm going to talk about you. You're a chump.
Anyway, I'll validate my position, which is this. I'm driving a truck, which has axles, which make noise. And I have auditory feedback in my ears to my voice, where I increase the amplitude of my voice based on how much roid noise. Right? It's not that I'm upset. So again, you failed. But anyway, I'll say it very calmly. Yeah, perfect. Yeah, so here we go, friend. The entire methodology of the rails, the only thing that must be accomplished for the principle in question is the rails must be parallel to the water. It's all that has to be done.
I agree.
And all you need is a methodology that makes the rails parallel to the water, and all that is a distance from the top of the rail to the water's surface, and that's all they have to do. All that other methodology and including calculations for Earth curvature is superfluous.
It is
sure. If you look at the document, they didn't actually measure it off the water surface. If you were to look at Figure 4,
oh my good gosh,
you can see that tank isn't full. They're not measuring off it. And Figure 7 shows that they're using the microscope and the string line and the rail to check the deviation.
That's fine.
Yeah, so I'm not sure about this particular setup, but the other setup, which we already critiqued the last time a guy came in here with tow tanks, is they have a water channel next to the rail, and they use that water channel as the leveling channel. It's not the water in the channel.
Well, I'd love to hear about that. So which tow tank was that?
They're assuming the aquapotential would be equivalent in both instances. So what they're doing is really, truly, they're just making the rail parallel with the water. That's it.
Yes.
You said so yourself. That's the ultimate goal, is that the rail is intended to keep the same drag line on the boat, continuous over its entire journey on the rail. Now, in order for that to be true, it must be what? Parallel with the water's surface. That's all they're attempting to do. No, which is assumed to be curved in your worldview.
No. Well, yeah, they assumed it to be curved. We gave them the prediction that if they set the rail at a certain curve, it would match the water, which came true. And predictive evidence is the only good evidence.
Listen, how are they making the curve on the rail, friend?
They get the string line and they
Listen, the only way to curve the entire rail
based on their model.
What's the length of the line?
Adjust the rail, though. They adjusted the line.
With it.
Wait, no, they adjusted the rail. They didn't adjust the line. You were wrong about that, Amy. Remember, you
so what I read was wrong.
They adjusted.
So what I read was wrong. That wasn't me freestyling. I was reading.
What you read didn't say they adjusted the line. If you look at figure 7, you can see that on the rail where they have 2 pins and they have a microscope pointing at the string. Okay? So that means at any given point, they can look at their model and they can see how far should the pins be from the string at this point.
So they didn't measure it in between the 2 points, right? Just like the laser test?
Say again?
So they didn't measure between the 2 pins, right? Just like the laser test?
They did, yeah. They measured between 2 things.
Right, but I still haven't gotten the answer to 2 questions.
In between the 2 points, because so if you have a curve, then you need that like the hump in the middle of the curve. So you're supposed to have
That's what the strings for.
The strings to measure the hump.
Yeah, the string is a reference. It's completely horizontal reference, right? So from 2 points, it will be.
Yeah, he also claimed.
2 points.
Yeah, before you continue, we got a caveat before you continue that the allegation is that they. Go ahead.
Excuse me, Indio. I'm trying to listen to Arden right now.
Yeah, well, no. So they presupposed the.
I yielded the floor, brother.
Just wait, Indio. Arden.
Yeah. Great. Stop moderating our fucking chat, douche. Okay.
Yes, if you were paying attention,
they took the rail.
I yielded the floor to Indio.
I know. I don't know why you have to say it again. Stop humoring this clown, okay?
My apologies.
So, listen, I'm not falling for the distractions, man. So they have this beam, right? This rail, and they can adjust the rail, and they pull the string. And so, what are they adjusting both at the same time until they're within
Why do you think they're adjusting the string?
Because they think the string has to be within a certain distance of the rail, right?
No. The string just has to be a reference, a horizontal reference.
But they don't know if the string's horizontal.
Yes, they do. If you get
How do they know that?
You pull it taut between 2 points with very little catenary effect, it is a horizontal. It is a straight line.
How do you know there's very little catenary effect? That's what I'm asking you.
Because that's what they say.
Yeah, but very little is also some. They're only seeing a small deviation, which is very little. So they're seeing the very little catenary curve. What are you talking about?
How do you know? You're assuming that because you're biased.
You just assumed that there's very little catenary curve. Your answer was because they said so.
Yeah.
Yeah, let me ask a question.
What is the value for the catenary curve? And then, how did they measure this? Because you're going to have 2 inverted curves, right? You have the curved rail, and then you have the curved string. And the curves are opposite to each other. So one's curving down and one's curving up.
And it's a very...
Yeah, but I also want to know how long...
It's so hard they can't even measure the amount of catenary curve in the string.
That's not my problem. That's your problem.
Right, no, but also I just want to qualify.
Some catenary effect doesn't mean that catenary effect is enough to screw up their model.
They have to measure it, brother. Otherwise, they wouldn't know. By the way, also, you were asked Hold on. It doesn't matter, dude. I just said they would have to. I'm trying to get to a different point.
The entire problem is that there's a catenary effect. Isn't that your entire problem at the moment?
Listen, the catenary effect is a constant in physics, bro. It can't be negated. Yeah,
but there are all sorts of problems that anything that you physically do, like there's some form of like tiny 0.000000001 problem in every single thing you do. But if it's not enough to screw up that thing, then who cares? It's like saying...
Right, so friend, for goodness sake, stop talking.
That thing can still work.
We all know that.
Volume. Jesus.
Okay, what I want is the brass tacks. How long was the string?
Doesn't know.
How was the... Shut the fuck up, kid.
Why?
Thanks.
All you're going to do is you're going to ask...
Because I'm trying to complete it, dude.
When the...
Alright, I'm just... Dude. These things matter. So stop frickin' sidelining. For goodness sakes. You were asked how they know it was horizontal. You just said they affixed it to 2 points. Being randomly affixed to 2 random points in free space doesn't prove that anything's horizontal. You then said they got rid of the catenary. That's how they knew it was horizontal. But you didn't prove how they knew it was horizontal.
Didn't have a great
Dude, I'm speaking. Thank you. You then said that they got rid of the catenary problem somehow for whatever methodology they used, which you didn't quantify. You didn't give us the length of the string, so we can't even calculate any of these problems to even begin to say. So far, all this is a fanciful assertion with no data and no quantification to it.
Yeah, the engineers made it. It worked. They referenced They reference the methodology they used. You just don't have the actual numbers in front of you, so therefore it's wrong. That makes no sense.
Dude, you haven't presented them. And your appeal, again, is just to the pragmatic at work. Dude, listen, the methodology they used got, let's just say for lack of a better term, it got the rail parallel with the water. Great.
Right.
What does that prove? Nothing. It just proves that the rail is pretty parallel to the water. That's it.
Pretty parallel?
Yes, because of the sentences that you just talked through, everybody, about error bars and all this other nonsense. You know it's not perfectly parallel. Good grief, dude.
So, Heretic, you said it's a pragmatic appeal again, but it isn't actually a pragmatic appeal.
It is. You said it works.
No, a pragmatic appeal would be for something unknown and unmeasurable.
What?
Where's the measurement?
It's for something unknown and unmeasurable, something abstract, like astrology work.
It is unknown. You already told us it was a gap in your knowledge, dude. You already told us the measurements that we needed were a gap in your knowledge, so they are unknown. And you don't have the measurements. Yeah, okay, how do you know? You don't know what they know.
You also admitted it was a gap in their knowledge because they didn't add it in there and have it nowhere presented, so...
Yeah, so let's link their engineering specs for this whole thing. Do you not understand that?
Right, but the other one that we did, bro.
Find a flaw that you can exploit in this when you guys don't have a single measurement of straight. Like, I gave a glaring flaw in your laser test. You
didn't. Actually, you just showed your ignorance. You actually just showed your ignorance.
I swear to God.
Did I, India? Do you want to talk about that? Do you want to? If I get 2 points across a bay and I just measure what point A and point B's temperature are, does that tell me the refractive index across the bay?
Good Lord.
1, 2, 3.
No, it does not tell you the refractive index across the bay.
It could.
Because
possibility.
You could. Could you explain how it could?
You could apply modeling and you could assume it.
They didn't apply modeling, though.
What is his point?
Yeah, why would you?
So they didn't calculate a value?
There is refraction. You need to establish that those models are correct.
But you can't establish if there's refraction unless you measure a difference across the bay, can you?
They did. They did have 2 meteorological stations at each end.
Yes, of course there'd be something different, Drace, you fucking idiot.
So you do know that the idiot 2 meteorological stations, right?
Yes. And they said meteorological station 1 and meteorological station 2 show X, but all that distance in between, they didn't measure any points on that and then map out the refractive index. Refraction doesn't happen between point A and point B. It happens the entire way in between. As any sort of change.
No, that's not how refraction works. That's not how refraction works.
Of course it does.
No.
Define it.
Light goes from one dense medium to another dense medium. All that has to be is a change in temperature, pressure, or like humidity of that air.
No, it's not. It's called optical density. It's not just the density of the medium.
We covered this with him before. Yeah, we've been over this optical density. He was furiously Googling or something.
You guys say it's optical density. Optical density can be changed by factors like temperature, the density.
Yeah, it can. But you also require the correct boundary conditions to those temperature gradients to be able to refract things, and you don't have those conditions all the time. And it also it depends on those angles and the optical gradients.
So you know what, like
the light can go up and down.
So you know what, like ISIL, not only did they horizontally pan it, they vertically panned the laser, and on top of that, they did it twice. They did it twice, 3 weeks apart, and they got the same result. So they just have like,
what does that mean?
So they have to have the same magical refraction conditions, the same 2-3 weeks apart.
And in different directions at different ranges. They didn't just horizontally pan the laser. They panned the laser horizontally.
It seems like they had different outcomes.
See, here you go again.
I'm speaking, brother. Okay.
AI, please.
Yes. They panned the laser to targets at different ranges. So, for example, in the 25-mile shot, the 25 miles was the final target, but they panned it through like a 4-mile target, a 14-mile target, etc.
And this was done 3 weeks apart.
Seems like they've got different.
The firing line is hot.
It
seems like they have different what?
They have different measurements for every single laser test that they did.
What does that mean?
Well, considering
different measurements of what?
They say refraction exists. Yeah, and they say